All right, today we're going to continue on with our operations of radical expressions. So we are going to be simplifying them, but mostly we'll be just looking at the dividing the radical expressions. So how do we go ahead and do that? The steps that we will take is first we're going to simplify the numerator. The numerator is the problem, so we want to attack that first. We want to look to see what needs to be done down there. So we're going to look at the denominator. Then we're going to multiply the numerator and denominator by whatever we need to make the denominator right. We're going to simplify the numerator, and then we can simplify if we can. Let me show you what I mean. All right, so here we have y to the 8th over x to the 7th. Now this x to the 7th is a square root, so see how we can separate them? That's okay, we can do that. But we have this square root in the denominator. We are not allowed to have square roots in the denominator. So the index here is 2, because it's just a square root. So if I'm looking at x to the 7, I kind of color-coded them just so you can see. The red, the green, and the blue are all paired up. But the problem is we have this one left over x. It needs a pair. So I need to add another x to this so that I can go ahead and pair this up, because I need the bottom, the denominator, to be perfect. Otherwise, it's considered not simplified. This process is called rationalization. So we will need to rationalize this. And so this is what we need to multiply by. But whatever we do to the bottom, we have to do to the top, because this is really just 1, and we're not really changing our fraction that way. Just changing a little bit of how it looks. So this will go ahead and allow us to have x to the 8th in the denominator. Now, yes, the numerator is a little messed up. That's fine. But we're going to go ahead and simplify the x to the 8th. That's x to the 4th, because we just divided by 2. And so that's what we end up doing. So first step was to take a look at the denominator and see what we need. Then we multiply. Once we've multiplied, the denominator should be fine. And now we got to simplify the numerator. Well, the numerator, the x to the 1st isn't going to do anything, so it's just the square root of x. The x to the 8th, y to the 8th becomes y to the 4th. That can't be the last step is always just look to see if we can simplify anything else, and those can't be simplified at all. So that is my answer. This may not look any better than what we started off with, but it is considered simplified, especially if we're going to have to add this to something. Having a denominator that's not a square root makes our life a lot easier. So this is when our denominator is a monomial. We're going to deal with ones with binomials in just a moment, but we're going to start with several that are monomials to start with. All right, so that's rationalization of this. Let's try another one. So here we have a cube root. Now remember, with cube roots, we're looking for groups of 3 with something. So here I have the 9x. I kind of want to simplify the 9x. I need the 9x is a 3 times 3 times x. But again, I need an index of 3, so I need a group of 3 of these. So I need to add an extra 3 here. That's why I got that blank there, to add an extra 3. I'm going to have to add 2 more x's. If I don't add those, I'm not going to get it perfectly paired up, and that's what I need to have for my index of 3. So because the index is 3, I got to have groups of 3, and so I need another 3 and 2 more x's. So I need another 3 and 2 more x's, or x squared. Again, top and bottom, I do them both. Again, it's called rationalization. So I go ahead and multiply those together. And on the numerator, I get 6x squared, and on the denominator, 27x cubed. Now that 27x cubed is just perfect, because when I go ahead and take the cube root of it, it's just going to be 3x. And then I'm looking in the numerator here. 6 is just a 2 and a 3. There's no three of a kind. And x to the 2nd, there's not 3 of a kind either. So that's as far as I can go. So here's another one with y to the 7th here. So I need to go 1 more to make it even, so y to the 8th, so that I can go ahead and reduce this and become y to the 4th. While I'm doing that, I'm looking at the numerator here, and x to the 3rd can be an x squared can come out, and just an x on the inside. And that's all I can do with those. So what about this one? I'm going to have to put, because there's groups of 3, I need 2 more 3s, so 9. And I need another y. So 9y is going to go in there. 8 cube root of 8 is just 2. So we're looking at C. All right, what happens when there is a binomial on the bottom, or the denominator? Then we have to multiply what's called the conjugate. We did this back with imaginary numbers and complex numbers. Remember, we take the denominator and multiply it by exactly what's there, except for instead of the plus, we're going to do a minus. And the reason why we do that is the square roots are going to cancel out. Back in the day, we did it with the imaginary, and the imaginary canceled out. But this is the same idea. So we're going to multiply this in order to get those to cancel. This is just to distribute here, so that's 25 root 3 minus 30. Here in the denominator, the middle terms are going to cancel out. That's what we did. So we just have the first term, which is 5 times 5, which is 25. Square roots of 3, square roots of 9. Square root of 9 is 3. 25 times 3 is 7. So that whole thing ends up being 75. 6 and 6 is negative 36. Subtract them, and we get 39. This is a big, giant mess, but we cannot simplify that at all. 25, 30, and 39 have nothing in common. If we have 4 minus 5, so we have to do 4 plus the square root of 5. Again, we just worry about the denominator. We don't care about the numerator. So we just worry about the denominator here. In the numerator here, we're going to how to square this out. 3 times 4 is 12. 3 times square root of 5 is 3 square roots of 5. 4 times 2 is 4 square roots of 2. 2 times 5 is square root of 10. Again, in the denominator, all I got to do is the first and the last because the middle ones cancel out. So 4 times 4 is 16. And this is negative square roots of 25. Well, square roots of 25 is just 5. So 16 minus 5 is 11. The numerator here is a big mess. This definitely looks a little bit simpler than this, but this is a big mess. However, it is a mess that we can deal with. And so this is considered simplified. And that's what I have for you today.